Welcome sa data structure. Ito yung ating finals part 1. Okay, we are going to discuss about sorting techniques. Sorting refers to arranging data in a particular format. Sorting algorithm specifies the way to arrange data in a particular order. Most common orders are numerical or lexicographical order. Importance of sorting lies in the fact that many data searching can be optimized to a very high level if data is stored in a sorted manner. Sorting is also used to represent data in more readable formats. Some of the examples of sorting in real-life scenarios are the following: the telephone directory and a dictionary. So we have types of sorting techniques. Now we have in-place sorting and not in-place sorting. No, so sorting algorithms may require some extra space for comparison and temporary storage of few elements. So ang ating keyword dito, temporary and extra space. No, so these algorithms do not require any extra space, and sorting is said to be happen in place, or for example within the array itself. This is called the in-place sorting. So sa in-place sorting, hindi na niya kailangan ng extra space dahil sinosort niya within the array itself, no, yung mga information. Ang example natin dyan ay yung bubble sort, no, that is an example of in-place sorting. Sa not in-place sorting naman, it requires extra space because it temporarily stores, no, the information being sorted in a separate memory that is not in place. No, ang example niyan is yung merge sort, no, which is an advanced at mas mabilis kesa sa bubble sort. No, stable and not stable sorting. Pag sinabing stable, if a sorting algorithm after sorting the contents does not change, take note, does not change, no, the sequence of similar content. For example, we have 26 and 26, the same sila, no? At isosort niya yon. Ang ibig sabihin ng stable sorting, hindi niya pinagpapalit, no? Kung ano yung sequence nung hindi pa sila sorted, ay ganun din ang sequence nila after na sila ay masort. Okay? That is stable sorting. Yung stable sorting naman, pinagpapalit niya right after na sila ay masort, no? That is unstable sorting. Next, we have the adaptive and non-adaptive sorting algorithm. No? The sorting algorithm is said to be adaptive if it takes advantage of already sorted elements. Kung may mga magkakasunod na dun sa loob ng array or sa loob ng list, hindi na niya yung gagalawin. No? That is adaptive. Sa non-adaptive naman, hindi na niya itinetake into account yun. Or basta isosort niya ng isosort ang information, whether it is already sorted or part of it is already sorted or not. We have also important terms, no, na dapat maging familiar with the topic of sorting. Number 1, we have the increasing order. The sequence of values is said to be increasing order if the successive element is greater than the previous one. For example, 1, 3, 4, 6, 8. This is an example of an increasing order. Next, we have the decreasing order. The sequence of values is said to be in decreasing order if the successive element is less than the current one. For example, 9, 8, 6, 4, 3, 1. This is an example of decreasing order. Non-increasing order, for example, we have 9, 8, 6, 3, 3, 1. So, ang ibig sabihin, the sequence of values is said to be non-increasing order if the successive element is less than or equal to its previous element. So, ito yung previous element, for example, 6, tapos may 3, tapos kasunod may 3 ulit. That is an example of non-increasing kasi meron siyang the same information or equal information, no, na kasunod. No? Pag non-decreasing order naman, reverse naman tayo. No? Yung kasunod niya, yung sumunod sa kanya ay equal to or greater than, no, the previous element. That is an example in the meaning of non-decreasing order. Now, for the first example ng ating sorting algorithm, we have the bubble sort. Ito yung pinaka-common, no? At sabihin nating mabagal na sorting algorithm, no? sa programming. So bubble sort is a simple sorting algorithm. This sorting algorithm is comparison based, in which each pair of adjacent elements is compared and elements are swapped. Yan, ito yung ating keyword. Elements are swapped if they are not in order. Okay? So ang ating complexity for bubble sort is O(n) squared, where n are the number of items. So how bubble sort works? We take an unsorted array. For example, we have 14, 33, 27, 35, and 10. So you notice hindi siya sorted. So isosort natin to using the bubble sort. So first, babasahin niya yung unang element and i-compare niya yon sa katabing element. Okay? Which is considered the first two elements. No? I-compare niya yon. If the left element is higher than the right element, isoswap niya yon, no? But if it's not, hindi na niya isoswap yon at mag-move on siya to the next element, no? So for example, 14, 33, 14 is less than 33, so no swap. Then move on sa next element, which is 27 compared to 33. 33 is higher, so we have to swap. So after swapping, we have 14, 27, 33. So move on to the next element, which is 35. 33 is less than 35, no swapping. So move on to the next element, which is 10. 35 is higher than 10. So swap. Okay, so swap natin. After swapping, we have 14, 27, 33, 10, and 35. Okay, so after first iteration, okay, notice nyo hindi pa siya sorted, no? So babalik uli siya sa unahan, ko-compare niya uli. Okay? Until manotice niya na itong dalawa ay hindi pa sorted, no? So again, 10 and 33, it will be swap katulad nito. So after swapping 10 and 33, we will have 14, 27, 10, 33, 35. So i-read niya ulit ito, okay? Hanggang si 10 ay mapapunta na sa first position, no, or to be as the first element dun sa array. So swapping, comparing and swapping ang ginagawa under ng bubble sort, no? So ito yung algorithm niya. So kailangan natin gumawa ng procedure named bubble sort, and then ilagay natin, indicate natin yung ating array. In this case, ang pangalan ng ating array ay list. Kailangan natin gumawa ng loop command, which is for, and also the condition, which will compare the elements, no, the two elements, and then end the bubble sort or the procedure if all the elements are sorted. Ito naman yung pseudocode natin. So again, ano meaning ng pseudocode? Combination niya ng algorithm at saka ng some English language and some command language. Okay? So ito ang ating pseudocode ng bubble sort. We declare the procedure for the bubble sort and indicate the name of the array and also the array items. And then we declare a variable named loop for the list count. Ibig sabihin, ito yung counter natin. So, gagawa na tayo ng loop para basahin niya isa-isa at i-compare isa-isa yung mga elements. Depende dito sa ating condition. Okay? If there's no swapping, the swap variable will become false. If there's swapping, this swap variable will become true. And if all the elements are compared and swapped, yan, so we use the and if, no, to terminate the condition, and also we use the and for to terminate the loop, no, kung lahat ay sorted na. So again, alam nyo na to, this is the array index, this is the array name, no? So we use the array index and the array index j, counter j, and we increment it by 1 to compare it to the next array element. Okay? So ito yung katabi niyang element, mas mataas sa kanyang element is si j plus 1. So kino-compare niya yung dalawa, and if there is swapping, the swap variable becomes true, and if no swapping, this boolean variable will become false. Okay? Yan. If no number was swapped, that means array is sorted now. Break the loop using the end for. The next in our example is insertion sort. This is an in-place comparison based sorting algorithm. Here, a sublist is maintained which is always sorted. For example, the lower part of an array is maintained to be sorted. An element which is to be inserted in this sorted sublist, it has to find its appropriate place and insert it there. Hence, the name insertion sort. The array is searched sequentially and sorted items are moved and inserted into sorted sublists in the same array. This algorithm is not suitable for large data sets as its average and worst case complexity are of the big O notation and squared, where n are the number of items. So the same with bubble sort, mabagal din siya due to this slow complexity. Okay? So, paano nagwo-work ang insertion sort? We take an unsorted sort array for our example, no? So sabi dito, nagme-maintain siya ng sublist and usually that is the lower part. Ano yung lower part ng array? Ito, no? So, in this example, we compare 14 and 33. So obviously 14 is less than. So at this instance, no? Si 14 ang nag-iisang sorted element, no? As a member of the sublist, no? So ito ang sorted sublist natin. Ito yung mga non-sorted sublist. So ito pa yung isosort natin. So we will compare this one by one with 14 and all other elements unsorted will be inserted, no? Kung ano man yung mas mababa sa kanya, no? So for example, 14 and 33, okay? So wala tayong gagawin dyan because 14 is less than 33, okay? We move on to the next data or information which is 27. And we compare 33 and 27, so we swap or we insert 27 between 14 and 33. So after swapping or after inserting, we move on to the next information and compare. So again, 10 is less than 33, so we insert 10 between 27 and 33. So we do this repeatedly until all of these elements are sorted. And this is the algorithm for the insertion sort, no? Step 1, if it is the first element, it is already sorted, return 1, no? Step 2, yan, may error lang dito. Yan, pakibago na lang. So we have 1, 2, 3, 4, 5, 6 steps, no? Sa ating algorithm, no? For the insertion sort. Pick next element. Third step, compare with all elements in the sorted sublist. Find appropriate position, insert the value, then repeat until list is sorted. Ito yung algorithm natin at ito yung ating pseudocode. So, kailangan uli natin ng array. Ang pangalan niya ay A. And i-insert na natin yung kanyang mga items, no? Using the insertion sort procedure, no? So, magde-declare tayo ng variable. Integer siya. Integer din to. All position, value to insert. And then we will use the for loop command to execute this until a certain condition or until all the elements in the array are all sorted, no? So, i-execute na to mga command na nasa loob ng ating loop hanggat hindi nasosort lahat ng elements sa loob ng ating array. Okay? So, after declaration sa loob ng loop, maglalagay tayo ng value, no? Initialize value to insert is AI. Again, this is array name and this is the index number. So, kung ano yung address, kung ano man ang value ni I, that would be the location and the value of the value to be inserted, no? Kung ano man yung value ni I, ito rin yung kanyang whole position where the value to be inserted is to be inserted. Okay? So while all position is greater than 0 and a minus 1 is greater than value to insert. So ito yung mag-determinate dun sa ating while loop kung yung mga condition na to ay hindi na valid, no? So mag-determinate siya, magbe-break sa while loop kapag si whole position ay less than 0 na. Ibig sabihin kasi noon, nabasa niya lahat yung array elements, no? And also ito, ibig sabihin nito, nakarating na siya sa dulo ng elements, no? Nagma-minus 1 tayo dito sa index number, no? Kapag nagseset tayo ng value ng total number of elements. Ang reason natin is, again, going back, no, doon sa property ng index number, it always starts with 0, di ba? So itong 10 na to, which is the first element sa array na to, ay 0 index ang number niya, no? So 0, 1, 2, 3, 4, 5, 6, 7. Pero ang bilang niyan ay 8 elements, okay? So ibig sabihin, 8 elements para ma-determine mo kung nasaan si 44, okay? Kasi ang total n nito is 8. Pero index number ni 44, ang last array or last element sa array natin is index number 7. So we have to minus 1 sa sa total number ng n. Whatever the value of n, we will deduct 1 to indicate the correct, no, index number of that array element. Okay? Yun ang reason kung bakit nagma-minus 1 tayo sa ating I variable, no? Ito naman sa all position, nagma-minus 1 tayo kasi we have to make whole position 0, no? Para ma-terminate natin to kapag naging less than, no, 0 na si whole position. Okay? So, if there's a need to swap at ma-determine na nyo yung whole position, then the value of the value to insert variable will be transferred to the array index number using the whole position variable, no? So pagka-swap, na-sort na lahat, then mag-i-end tayo ng loop at mag-i-end tayo ng procedure. And that's the pseudocode for the insertion sort. We go now with selection sort, no? Selection sort is a simple sorting algorithm. The sorting algorithm is an in-place, again, comparison-based algorithm in which the list is divided into two parts. Sorted part at the left end and the unsorted part at the right end. Initially, sorted part is empty and unsorted part is entire list. Smallest element is selected from the unsorted array and swapped with the leftmost element, and that element becomes part of the sorted array. This process continues moving unsorted array boundary by one element to the right. This algorithm is not suitable for large data sets. The same with the bubble sort and insertion sort because it has a complexity or worst case complexity of O(n) squared. So how selection sort works, we take the example below. Okay, we take this array and we read it the first position, which is 14, and then 14 will be initially compared to the other unsorted list or elements, no? So when comparing, mababasa natin na pag ni-read natin to or nung machine, no, makikita niya na si 10 is less than 14, so we will swap their position, no? So the machine will swap their position. 10 will be as the first element and 14 will be at the position, the previous position of 10, no? Since 10 is the first member, no, of the sublist, no, as the sorted element, we will move on to the next element and read, no, the unsorted part and compare this 33 value with the others, no? So pag binasa niya to, makikita niya na si 14 is less than 33, so silang dalawa naman ang iswa-swap, no? So pag swap niya, we move on with 27 and read the unsorted elements and compare. So pag nahanap niya yung mas bababa kay 27, again, magswap sila ng position, again, move on to the next element. And then compare again, search again, kung sino yung mas bababa sa 33, and in this case, si 27, so swap the two elements and then move on with the next element. And we do this, the machine do this until everything is sorted. The algorithm is step 1, set mean, meaning minimum elements or minimum value to location 0. Search the minimum element in the list and swap with value at location minimum, increment mean to point to next element and repeat until list is sorted. Yan ang ating algorithm at dyan nakabase ang ating pseudocode. Again, we will make a procedure called selection sort, no? And then declare a list array, name list, and also declare the size of the list, no? And then we use again the for loop command to execute all the commands inside the procedure until every element is sorted. So set current element as minimum. So minimum equals I, which is currently initialized to 1. And then check the element to the minimum to be minimum by doing another loop. And inside the loop, we have to make a decision or an evaluation, no, using the if and end if command. Okay? So, searching the list, the minimum from the list, and comparing it to the current element, we can determine if the swap, no, if there is a swap between the minimum element and the current element. So if the index min is not equal to I, then swap list minimum and list I, and then after swapping and if all the elements are sorted, end the for loop, and then end the procedure. So that's it for the first part of our finals. Now, the second part, we will continue discussing the merge sort algorithm and other advanced sorting technique.